Many squares are inscribed in a triangle as shown. Find the sum of the areas of the square. Without wasting time, the sum of the areas is equal to the base, which is 2, times the height, which is 6, all squared over 2 plus 2 times the height. Yes, that's the formula. So if you factor 2, 1 plus 6, our answer is 36 over 7. So that's it. So let me prove how I use this formula. It will take time, but I will prove it. So we're going to use similar triangles. So let's get the height of this small triangle, because this is a square. Let's call the side of the square x. So here is x, here is also x. So we have two similar triangles. So if we join the heights, like we get the height, we see that from here to here is x, because it's a square, while here is now h minus x. So using similar triangle theorem, we have that h minus x over h, that's this one over the long one, h, will be equal to x over e. That's by similar triangle theorem. Because triangle E, that's because triangle EAB is similar to triangle EFG. That's this small triangle is similar to the big one. So let's open up, let's simplify. This is 1 minus x over h. We have x over e. So our main aim is to get the side, which is x, in terms of h and e. Okay, so we collect like terms. We have, this goes over, so we have with 1 here. So x over e plus x over h. And if we factor x, we have 1 over e plus 1 over h. So which is, if you simplify this, we have eh, while here is e plus h, 1. So making x the subject of formula, therefore x is now eh over e plus h. So that's it. That's how we got the formula. That's the side. Once a square is inscribed in a triangle, you are given the height of the big triangle and the base. So it's just the product of the height and the base over their sum. Okay. Since we've known that we've gotten that x from the first analysis, that x is EH over E plus H. We can now relate it to Y and Z. From the diagram, remember we said we said from here to here is X, meaning that the remaining, let's call here H, the remaining height will now be H minus X. Y, if we call here the length here Y, the remaining, the height here will now be H minus X plus Y. Yes, since we said that here is X, here is Y, so the remaining height will now be H minus X plus Y. So we can see that y now, y is our h in y is the height is h minus x. Okay, remember we'll call here, let's call the base, remember we used here to be e. So is now our base here for this try is x. Do you get the base here? I'm saying from here to here is x, because so it's now x. Why the height is h minus x over x plus h minus x, which is x h minus x over h. So we'll substitute the value of x, which is y is now equal to x is eh over e plus h, h minus eh over e plus h over h, which is equal to, if we factor h, so h will come out, we are left with 1 and we are left with e over this, so that h will cancel this, we now have a h over e plus h, 1 minus e over e plus h, which is now equal to the LCM, that's this is e plus h times the LCM is e plus h, this minus this is h. So what do you notice is now equal to eh squared over e plus h all squared, as what we used in the former equation. E is 2, y h is 6. Do you see why we use this? So let's finish off with z. Z is now, the height for z is h minus that, y the base, that's the base of the triangle, is now y. So we now have y times h minus x plus y over y plus h minus x plus y, which is equal to y times h minus x minus y over h minus x. So we now substitute the value of y and x. So we substitute the values of x and h. So h is e h squared over e plus h all squared. Y is h minus eh over e plus h minus eh squared over e plus h all squared. So we substitute the value of x and y in terms of eh. Y this is h minus eh over e plus h. So as you can see, h is here. So we'll factor it. We're left with eh squared over e plus h all squared. This is 1 minus e over e plus h minus eh over e plus h all squared. So we factored h and we cancelled. This is 1 minus e over e plus h. So z is now equal to, as you can see, this is eh squared over e plus h all squared. The LCM is e plus h all squared. This in 1 times that, so we have e plus h squared minus e times e plus h minus eh divided by LCM here is e plus h, this in there, so we are left with h. So this is equal to, as you can see, h e plus. So we are left with 1. So we are left with E over, that's EH over E plus H. This is gone. 1, 1, 1, 1. So we're left with that. While looking at this, E plus H is common in both, so I can factor E plus H. And we are left with 1 E plus H minus E over E plus H all squared. Which is equal to EH over E plus H. Looking at this, we are left with H. And again, H is common in both, so we can bring out H. And we're left with E plus HY minus E here over E plus H all squared. You get E plus H minus E is H, and H is common in both, so bring it as we are left with this minus E. So this is now H times H squared times that, so we have EH raised to power 3 over this times this is E plus H all raised to power 3. So have you seen analysis since we've proved that if the length of the side of this square is x, y this is y, and this is z, that x is always okay if the height of the triangle is h and the base is e, that x is equal to EH over E plus H, y is EH squared over E plus H all squared, and finally z is EH cubed over E plus H all cubed. So these are the sides, meaning that the area is now E squared, area of the square, which is EH over E plus H squared. Y squared is EH squared over E plus H all squared, all in squared. Finally, Z is EH cubed over E plus H cubed, all cubed. From this, you can see that the areas are in geometric progression. Yes. Because if we do y squared over x squared, we'll get h over E plus H all squared. Yes, check it. If I do this over this, that's what I will get. The square is common, you bring out the square. This over this, H, we are left with 1H. This, we are left with that. And if we do z squared over y squared, we still get the same H over E plus H all squared. Check it now. This is squared. This squared. So we'll get this. Check it now. This over this, H cube H. We are left with this. We are left with E plus. So this is the geometric progression. So meaning that if we are to sum to infinity the areas, so we now have sum to infinity. Therefore, the sum of the areas, which is sum to infinity, is T1 over 1 minus R, where T1 is the first term. Our first term is EH over E plus H all squared, and our common difference is H over E plus H all squared. Yes, using geometric progression. Yes. Therefore, we now have that the sum is now equal to, therefore the sum of the areas, which is sum to infinity, is equal to, our A is EH over E plus H all squared over 1 minus H over E plus H all squared. So this is equal to E squared H squared over E plus H all squared divided by, this is the LCM, that is, this is 1 minus H squared over E plus H all squared, which is equal to E squared H squared over E plus H all squared divided by, the LCM is E plus H all squared. This this over 1 times that to E plus H all squared minus H squared. So we'll continue. The sum is now equal to E squared H squared. Okay, this, you get, divided by this. So we now left this. So we are left with this over E plus H all squared minus H squared, which is E squared H squared. This difference of two squares. So this plus this is E plus 2H. Why this minus this is E. So we have EH squared over E plus 2H. So have you seen it? Have you seen why we solve this fast? Times H squared, that's E times H squared over, that's E times H squared over E plus 2 times H. Do you see it? So it's from there that we derive the formula. So our answer is option B. That's the area. Thank you.